multiple regression and the polynomial regression. Yes, and some matrices, regression matrices, that is R2 score and adjusted R2, MAE, MSC, RMSC. So that part is clear to everyone. Please reply.
Yes, sir.
Yes, sir.
Okay,
That part is clear.
okay, good. So now I'm
Yes, sir.
coming one problem. Okay, so that problem. Okay, so this color is visible or have to go for
No, sir.
white one.
Hi, sir.
Okay, so I'm coming for white one. Okay. Yes.
The screen.
Okay, so I'm
मेरा
sharing my
screen नहीं
screen
दिखा.
just okay,
The
wait,
screen is
wait.
not
So
visible.
yeah, just I'm sharing my screen. Wait. So now visible? Yes. Everyone is okay?
Yes,
Yes, sir.
Okay,
Yes,
yes,
sir.
sir,
okay.
not
Yes, sir.
visible.
Okay,
Visible.
so I think you some of the student have done this part. In the polynomial, I have given you one thing, that is the degree part. Okay. So means you can say, sir, data is like that. Okay, somehow data is like that. In the last class, we have also discussed this thing. So maybe you can find a curve like this or this. Yes. So it may give the pattern, but somehow if you will increase the degree, maybe first part is the degree 2, second part is the degree 3, and if you are taking the degree 200, okay, or more than that, so what will happen? Data will try to take all the points like that. Yes.
Yes.
So maybe you are getting this type of pattern if you will increase the degree. Okay. So the actual pattern will be taken by the machine learning algorithm or the regression. Yes. So every point if you are taking, so the system or you can say the model is complex. Yes. Everyone is with me for this thing? Yes. Hello. Yes or no?
Yes, sir.
Yes,
Yes,
Okay.
sir.
sir. Yes, sir.
Okay, very good. At this time, if you will go for the testing, means if you are saying these points, whatever I have draw here, that is the points are training point. Okay, these are the training point. Now, if I am taking the data as a testing point, some data here, some data here, some data here, some data here. Now, if you want to capture some pattern with this data, the error will be more. If you will see, this is the part.
Yes.
Okay. And if I am taking the degrees like that, so here first thing is that you can't predict what is the pattern of this whatever the data is given to you, because this is a complex pattern and you can't say, and every time you can find that is the error will be more. Yeah, error will be more. If you will see, this point is here and this point is here the error. But for the more degree, when the data is captured, when the model is taking every data, the error will be more. Even though I'm unable to draw this thing, but every time if you will find when the training data, training data, yes, sorry, this training data, when the training data involved, every data is involved in the system to create a model. मैं easier example ले रहा हूँ. This is the thing. This is your training data. Okay. And you are trying to find the pattern. So maybe the pattern will be look like this. Okay, maybe. Okay, I can say maybe this is the pattern. Okay, it is trying to take all the data. So sorry, not this actually. This is your pattern. Okay, maybe this is your pattern. And on the basis of simple regression, if you are applying, maybe the second thing is that whenever you are trying to take the testing data here, so one is the error is here, something this is like this, some error is here, some error is here, and some error is here. For this pattern only this error is happening. So every time you will find whenever we are capturing some data like this, This is providing less error, and whenever we are involving all the training data, the error will be more. So the real picture, if you will apply the real data set, you will find this type of picture. So we can say, sir, this type of thing, whenever this type of thing is occurring, you can say that is the overfitting part. Overfitting means every time whenever your training data involved to take capture the model. Okay, every data is taking participation to capture the model. So overfitting will come in the picture. Otherwise, second thing, what will happen if the data is like that? Okay, and somehow only 1 and 2 points are involving to take the to 1 or 2 points are training points are involving to capture the model. So that type of situation will occur. Then you can say that is the underfitting thing. Okay, yes or no? Yes. Please reply.
Yes.
Okay, so we can see these two terms in terms of bias and variance also. Bias and variance. This variance is different, whatever we discussed in the PCA. Okay, the definition is different of this variance. So I just try to make you understand with this thing, bias and this variance. Now I am taking one example again. Okay, so okay, maybe this is the data and the actual pattern may be this. But with the regression model, we find this type of curve, this white curve. Yes. So now we will try to find out the error. Okay, this may be the error, this may be the error, this will be the error. Okay, this is the error. Okay, first of all, I am taking only the error thing. So these are the these. So these points are the training points. So we can say this is the training error. Now you just tell me training error, if we are coming, if the training error is more, then what will happen? It will be underfit or overfit. Training error is more because I have told you about the overfitting. Acha, tell me, when every point is taking part to take the model, the error will be overfitting. Just wait. In this part, when you are taking about the training error, what will be the training error in this part for this red curve? Tell me. Every data is taking part to create a model. Then the error?
Yeah, on that time it will be overfitting.
No, no, I am
Error
not.
will be high.
I am asking about what should be. It will be less, zero. I think that point is not means clear to you. Okay, I am taking this thing. Please, this is your data. And every point, this is your training data. So what is the error at this time? Error क्या होता है?
इस टाइम में एरर
Error क्या
जीरो है.
होता है?
Zero, sir. Zero, sir.
Zero ना?
No error.
Okay, so
Yeah,
training error zero
no
because
error.
every data is taking part to create the model. Yes? So training error is zero at this time. Okay? Now you just tell me, इस वाले पार्ट में एरर आपकी क्या है? बहुत ज्यादा आ रही है? Yes?
Yes, sir.
तो
Yes, sir.
Yes,
मैं
yes, it is
अभी के
coming.
लिए for the layman term you can say this training error you can represent that is the bias. Sorry, spelling एक बार देखना bias की. Yes, okay. So bias is zero at this time when all the data is taking part. Yes, training error is zero. Clear? Okay. और इस टाइम पे क्या है आपकी? This time the bias
More.
is high. You can say
More
high,
high.
high. Okay. Somehow this is zero, this is high. So you can say this bias is low. Okay. Now I will tell you. Now in this model, I will put the testing data. Okay. The color is somehow we can take green. Okay. This is the testing data. Okay. And you can say this is the testing data. Okay. Tell me if this is the error. So second error, you can say that is the testing error. You can relate this testing error to the variance. Okay, this is not actually means you can say is equal to, testing is not equal to variance, but you can say that is the proportional thing. Okay, variance is equal to proportional to the testing error. Yes. So now you can tell me the testing error, somehow this testing error or this testing error, which one is more? Tell me, what is your assumption? Variance यहाँ पे कैसा है?
यहाँ पे हाई होगा सर,
कहाँ पे? इस वाले में? ओके,
राइट
दिस इज
साइड वाले
हाई.
में।
या भले ही वो डायग्राम में उतना मैं क्योंकि हाथ से बना रहा हूँ, दैट इज नॉट विजिबल, बट एवरी टाइम इफ यू विल से whenever the bias is low, means every point is taking part in the training, okay, training time, then the variance, you can say the testing error will be high. Okay, and in this scenario you can say somehow this high, this is the high, this will be low than this value. Okay, yes, so this will be low than this value, I am saying. So you have to find out the midway. Okay, in both of the cases we don't want this type of structure or model, this type of model, we don't want this type of model. We want the model like the variance should be low and the bias should be low. I will show you this picture with some code or something. So try to understand what is happening. First I am telling you, so just tell me, okay, one thing I just want to relate the here only. So whenever the variance is high, this type of model, you can say this is the overfitting. Yes, already I have discussed this part, this overfitting
Yes
part.
sir.
Yes, and whenever the bias is high, you can say this is the underfitting. So remember only the two things, otherwise you will confuse in the underfitting or overfitting. Just remember the high thing. Whenever the variance is high, that will be overfitting. Whenever the bias is high, that will be the underfitting. If you will remember on the basis of low, you will be confused every time. So remember with the help of the high. The variance is high, then you can say the overfitting will be there. The bias is high, that will be your underfitting. That part is clear to you? Yes,
Yes
everyone
sir.
is clear?
Yes, sir.
Yeah. So
Yes sir.
we have to find out the midway, or you can say we have the trade-off between these two things, variance and biases. So whatever, so every time we have to go for the variance is low and bias is low. Means some error will be there, the testing error will be there, some training error will be there, but we accept that model. Okay. So, so every machine learning model should have the low variance and low bias. This part is clear to you? And I
Sir.
will I will show, yeah, I will show this part
Yes, sir.
with the help of one code today only. Okay. Before that, most of the time when we are working on the machine learning model, this type of problem occurs, overfitting. For the underfitting, if underfitting problem is occurring, what we can do, we can increase the data, we can do other exercises, but most of the time this type of problem will occur. So we have to remove this type of problem. Means every time you are reducing the overfitting. Whenever the underfitting will come, we will go for different type of data set. Okay, that is the one way only. So most of the time when you have done your exercise, you will find some overfitting is there. Means in the regression problem, what you will find? You will find the R score. Most of the time you will find the R2 score. Okay. On the basis of that, you will find, sir, R2 score to utna acha nahi aa raha, what I can do? Okay. So whenever the R2 score not coming appropriate, we can go for the different type of situation, different type of models again. So one thing is there, if the overfitting is problem coming, overfitting problem is coming, then we have to reduce that problem. So there are some ways to reduce this problem overfitting. Okay, so one by one we will go for this thing. So that one word is the regularization. So we will use the regularization or some bagging and boosting. There are two things also, some bagging and boosting. So bagging boosting we will cover up in the when I will teach you the classification problems. So then I will cover up this part. The regularization I will cover up with this regression problem. Most of the time, whenever the regression problem you are solving, you will go for the regularization. Okay. So what is the regularization? First thing is that if the model have the overfitting problem, we can reduce that problem with the help of the regularization. That part is clear. And what is the regularization? Now I am telling you. So till now you are with me. What problem we are means facing and how we will going to reduce that part or overcome that part. Yes or no?
Yes, sir.
Yes, sir.
Yes. Okay. So we have the three types of regularization. One is that is the you can say that is the raise regularization. Okay. Second is lasso and third is elastic net. Somehow you have done this thing somewhere you have. So ridge regression, you can also take the name L2, yeah, L2 regularization. And this is the L1 regularization. And last one, you can say this is the combination of L1 or L1 and L2. Yes. So these three type of regularization technique we will study and how they are doing how they are reducing the overfitting problem. So we will do this part. Is it okay? Yes, everyone
Yes, sir.
with me.
Yes.
So what we are going to
Yes, sir.
done?
Yes.
Yes.
Do sorry.
Yes.
Yes. So first of all, I will give you some intuition. Okay, then we will go for this thing. Again, I am making because we are learning again and again this type of graph. So again, the problem is regression. This is the line. So what is the equation of this line? That is the y is equal to mx plus c. Okay. So there are two variables again, this m and this c. Yes. Okay. So what is happening? If I am saying, if I am making this line and I am trying to make second line like this, some lines like this. So if we are increasing in this way, what is happening? The m is increasing. Yes or no? Yes, tell me. If I am taking c is constant or
Yes.
say whatever the value is changing c, that is okay. No problem. If the value of c is changing, that is okay. But if you are seeing this part, the slope is increasing. Okay, if we are taking parallelly to y-axis, so you can say, sir, the m is infinite. Yes, slope is infinite in this way. Yes. So in
Yes.
this part, the slope is increasing. When we are taking the data in this part, the m is decreasing. Yes. In this part, m is decreasing. So there are two things. Most of the time, what you will do in the regularization, the value of m, you are decreasing. What is happening? Try to understand what we are doing. So again, I am taking one example so that will be more clear to you. So I am taking one example that is we have only two data, two training data. Okay, these two training data I am giving the name. This is x1, this is x2. So the value of x1 I can say this is 1, 2.3. This is x2. So this is you can say this is 3 and this is 5.3. Okay, randomly I am choosing 2 points. These are the 2 points. And on the basis of that, I can find a model. So इसका मॉडल क्या निकल सकता है? Anyone can tell me? तो दो पॉइंट है, क्या मॉडल होना चाहिए? So you can say, sir, if we have only 2 points, so that will be the equation that is equal to y is equal to mx plus c. Okay. So this m and c value, because there are 2 points, so directly you can find. So वो मेरे पे है 1.5x plus this is the x and this is the y. So you can say, sir, this is y is equal to 1.5x and this is 0.8. Now, what is happening in the system? Some testing point is like that. Some testing points are is like that. Some points I am putting. So what will happen? Actually, when you are going for the training thing, the line is coming here. And when we are going for the testing, the line should be like this. Yes. So that will be more appropriate line if we are going for the testing thing. Yes, yes or no? Tell me. समझने की कोशिश करो क्योंकि ट्रेनिंग के पास दो डेटा था हमारा, तो मैंने दोनों लाइन से निकाल दी क्योंकि दो डेटा पे मैंने कहा कि आपके ट्रेनिंग के सभी डेटा इन्वॉल्व यहाँ पे हो रहे हैं या ज्यादा से ज्यादा डेटा यहाँ इन्वॉल्व हो रहा है, वो हमारी ट्रेनिंग कर रहा है। एरर बायस आपका यहाँ पे कितना है? बायस यहाँ पे हमारा 0 है। ठीक है, बायस अभी कितना है? 0 है। बट जब हमने ट्रेनिंग टेस्टिंग डेटा को लिया जो पॉइंट पॉइंट से दिखाया है, यहाँ पे एक्चुअल लाइन अगर मैं ये लेता तो इट विल बेटर परफॉर्म। So what is happening? Try to
Yes.
understand. Yes. So what is happening? इसको इसमें भी मैं इसी पॉइंट्स पे दो पॉइंट पे ले ले रहा हूँ। इस टाइम पे एरर कितना आ रहा है? ये पॉइंट एरर हो गया, ये पॉइंट्स पे एरर हो गया, इतना पॉइंट डिफरेंस आ रहा है ना। इस वाली लाइन से इसको अगर सेम पॉइंट पे मैं डेटा को एक्स की वैल्यू कुछ प्रोवाइड करूं सेम डेटा पे तो कुछ पॉइंट आएगा। तो इस लाइन की इक्वेशन में लिख दे रहा हूँ दैट इज इक्वल टू y इज इक्वल टू 0.9 x प्लस 1.5। So what is happening? Try to understand. मैं एक इंट्यूशन दे रहा हूँ। सो रेगुलराइजेशन या कुछ और टेक्निक में लगा था तो उससे मुझे ये वाली लाइन को फाइंड आउट करना था। आई जस्ट वांट टू ट्राई फाइंड आउट दिस लाइन इंस्टेड ऑफ दिस लाइन। सो आपका स्लोप में क्या आ रहा है? स्लोप आपका एम क्या हो रहा है? डिक्रीज हो रहा है। यस
Yes, sir.
यस। So we are trying to decrease the slope, but that slope should not be decreased to 0 or something. That should be some optimized value कि जिससे हमारा R2 का स्कोर भी इंक्रीज होता रहे। सो वी हैव टू फाइंड आउट सम वैल्यू दैट सम स्लोप वैल्यू दैट शुड बी डिक्रीज्ड वैल्यू। तो इसको फाइंड आउट कैसे करते हैं, क्या करते हैं? तो ट्राई टू अंडरस्टैंड। हम क्या करते हैं कि वी हैव वन लॉस फंक्शन व्हेन वी आर ट्राइंग द सिंपल रिग्रेशन, वी हैव द लॉस फंक्शन लाइक some value yi minus yi cap, that is the square. That was the loss function at when we are derivate the things and find the value of m and c. Yes, okay, in the simple regression ये तो एरर लिखा हुआ है, एरर का स्क्वायर है, वो हमारा लॉस फंक्शन था। नाउ आई एम सेइंग आई विल ऐड वन मोर टर्म, that term is lambda m square. Okay, so again you know this thing, what is the value of m, what is the means of m here? That is the slope. In some book you will find this type of thing, this w and square. Now in the layman term I am telling you, then I will come to this. This is the vector thing actually. W, this is the weights, so that will be m1 m2 m3 m4 or w1 w2 w3. So that is the vector thing is written here, so you can use the w or m whatever. Okay, so what's the simplicity I am telling you, because I am taking only the one equation, that is mx plus c, I am using the m square. So you can understand, sir, something is happening with the slope. And what is this? This lambda value is the hyperparameter. So hyperparameter, for the time being, you can understand, you can adjust this thing by yourself. You can take any value starting from 0 to infinite, or you can take this is negative value also sometime. Okay, so this is the hyperparameter, you can adjust this thing. So you can say that that is the tuning factor also. Okay, so this hyperparameter you will choose, and something that is m is given by the with this equations. Okay, so you will find now, if you will want to do, you will find the value of m and c. Again you can do that dl by dm 0, and you can put dl by dc is equal to 0. You will find the value of m and c. So that is the mathematics. So this time only your equation has been changed for L2 regularization, or you can say that is the ridge regularization. Okay, why we are say I am saying this is the L2, because every time you are using the m square value, अगर यहाँ पे ये मल्टीपल रिग्रेशन होता, so what is happening that time, some more slope will be there, that m1 value, m2 value, m3 value, and so on, mn value. Yes. So what will happen, I will add that value with the square thing. Yes, I will square that part and I will use the this part. Okay, lambda m1 square mt square dot 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 mn square, whatever how many value you have, you can do this part. Clear? Yes, everyone with me? कोई तो
Yes,
बोल
sir.
दो यार. Okay, good.
Yes, sir.
Yeah, very good. So this is the L2 regulation. So what is now what you can see or understand with the common sense, you can say, sir, if I am adding something in the loss function, we can increase the value of R2, means R2 score you are increasing. Yes. So why actually this is happening? On the basis of these value, these equation, I can just want to tell you. So you can fix the lambda. Lambda is equal to 1 and lambda is equal to 2. Oh, so, again, this is 1. Okay. So what is happening for the first equation? Try to find out. For the first equation for this line, what is happening? Try to find out this loss value. What will be the value of this thing? Tell me for these 2 points. Huh? What will be the error for these 2 points? It is overlapping. So again, already you have told, sir, bias is 0. So error will be 0. The training error for this line, I am taking first equation for the y is equal to 1.5x plus 0.9. Yes. And second equation I am taking, that is कितना था? Y is equal to 0.9 and 1.5. ये 1.8 है, sorry. Okay. So this is 0.9 x plus 1.5. This is the equation. Yes. So now I am using the loss function. I just want to find out the loss function. So what is happening? The error part. The error part, because every point is going through with this point only. So the error is 0. Yes. So you can see, sir, this is 0. We are using this formula. The lambda value is 1. So I can fix that 1. And what is the slope is here? That is the 1.5. So you can say, sir, this is 1.5 and I am square that part. Okay. So the error will be 2.25. Yes. The loss is 2.25. Clear, everyone? Okay. Now, if we will
Yes.
find the loss for this equation, now the value of x, you can see here, the value of x is 1 here. And if you will find this thing, for the first equation, first I am writing the equation, that is 2.5, 2.3 minus 0.9 minus 1.5 square plus 5.3 minus 2.7 and minus 1.5 square. Then I will write that is 0.9 square. From where it is coming, try to understand the equation y is equal to mx plus c. Okay, this is the y cap and actual y is given to you. First y is you can see that is the 2.3. Yes, this part. So I have putting this thing 2.3 and after that I am putting the value x is equal to 1 here. The value will come here. So that is the square thing. Clear, everyone? So second y2 value is there and after that 2.7 minus 2.3 जो भी है आपका, after that you can find this value. So that is the on the basis of that, if you will find the value of loss, the loss will come directly. I am putting that is 2.03. This will be the loss. Okay. So after adding some value, okay, here some value, something I am adding, on the basis of that I am reducing the loss. Yes. So this is the benefit of the regularization. Every time the RT score will increase, the loss will decrease. Okay. And you can you can take the intuition, sir, the m value is decreasing. Okay, so every time when we are going this type of thing, most of the time you will see the m value, the slope value is decreasing. Okay, or will be decreased. Clear this point, everyone? So this is the
So,
main intuition. Yes, question.
so we have to calculate the value each and every point all the time.
No,
Just like
yes,
just
yes.
you have
Normally what will
x1 and
happen,
x2.
yeah, normally what will happen, you will get the equations. Okay, and directly, normally, if you will apply the mathematics, you have to do this part. But already we have some libraries of this thing, so you can directly use that library and you can attempt this part. And second way, by this loss function, okay, with this loss function, you can find the value of m and c directly. Yes, for this to find out the this value, this equation. This is the, again, this is the regression thing. So for showing that your loss is decreasing, I have taken this example. Clear? In the regression, what you are doing, again, you are finding the mx plus c. You are finding this value and this value from the simple regression. Again, in the regularization, you are finding this value and this value. These value will be different. So normally simple regression, this value will be more than this value when you are using the regularization. The intuition is that part. Is it okay, beta?
Okay.
Yeah.
Yes, sir.
Okay.
Okay.
Good. Good. So I believe means the you understand, because the loss is decreasing, we can apply or we can find this type of thing. Is this okay to everyone? Clear? Okay.
Yes, sir.
Yes, sir.
Okay. Good. Good. But when you, I just want to tell you the advantage or disadvantage. You can say that is the disadvantage. Every time when you are using this type of thing, loss never will go to the zero. Okay, it will not will go to the zero, even though it will reach to the tends to the zero, but it will not go the directly zero. Yes, so this is, so I can show you one code for this, so you can more means more visible thing will means for understanding purpose. Okay, so I just want to show you one thing, what will happen. So one graph is there, this is the graph. Okay, so we have used some different lambda and we have putting this thing. So you can see here, for it is going tends to zero, but every time when we are increasing the value of you can say different lambdas value we are increasing, every time you are finding that is it is going tends to zero, but never it will reach to the zero. Okay, so remember this part till now, just remember this part, because when we are going for the L1 thing, the loss will reach to the zero. So there is some significance of this part. Okay, so that's why I'm saying this is the disadvantage of L2. That's why we are using the second type of thing, or you can say that is the lasso regression or regularization. Lasso regularization. Only the difference is that now anyone can tell me what should be the difference? This is the L1 regularization. तो common sense से आपको क्या समझ आ रहा है? Only the function will change again and again. All the thing is same. Means again the overfitting problem will be reduced by this lasso regularization, and you can say, sir, same. This is yi minus y cap I square. मैं यहाँ पे पिछले में यहाँ पे I is equal to 1 to n नहीं लिखा था, so you can understand. And here the lambda will be same, but the only thing will change, that will be here the value m will not be squared, that will be the absolute value. Yes. So you can say because the power is 1, you can say this is the L1 regularization. That part is clear? Yes. Please reply.
Yes, sir. Yes, sir.
Okay, good. So because the power is 1, now again, if you want to find out the value of m and c, you can again you can do this lambda m is equal to 0. and del L lambda C is equal to 0, and you can find the value of M and C. Here again, the same procedure is there. But the advantage of this thing is, again, I am telling you, when you are going for the loss function, you can find most of the time the loss will be 0. Yes. So what is happening here when the loss is 0? So again, I am telling you with the help of the code. Just wait. अभी इसको पूरी तरीके से दिखाता हूँ. Just wait. ओके, इसमें नहीं है. एनीवेज, मैं इसको समझाने की कोशिश करता हूँ. You have some means features, means x1, x2, x3, x4, x5, and xn. So what will happen when you will apply the L1 regularization? What will happen? The coefficients will come. The coefficients of means आप समझ सकते हो कि अगर इक्वेशन कुछ बन रही है तो the equation will be look like this. This beta 1 x1 plus beta 2 x2, this beta 2 beta 3 x3, और मैं डॉट 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 xn कर देता हूँ, beta n xn. Yes. So this is the equation, some equation of the linear regression. Yes, or this is y. Okay. Now I am saying the coefficients value. जो मैंने जो आपको समझाने की कोशिश की थी कि loss will not be 0. So try to understand the coefficients value. Some coefficients value will reach to the 0. ओके, यहाँ पे कुछ अभी 7 ले लेता हूँ, ये 3 की वैल्यू 0 हो गई. ठीक है. आपके रेगुलराइजेशन में क्या था कि किसी भी कोफिशिएंट्स की वैल्यू, सॉरी मैंने लॉस लिखा वहां पे, लॉस भी हो सकता है, लॉस भी लिख सकते हो. कोफिशिएंट्स की किसी की भी वैल्यू दैट विल नॉट रीच टू द 0. इवन इट विल रीच एट द 0.00001, but it will not be absolute 0. Yes. But in the ridge regression, what will happen? The value will reach to the 0. Some coefficients value will reach to the 0. So what is the advantage? अगर इस coefficients को 0 कर देता हूं तो ये coefficient गायब हो गया, ये फीचर गायब हो गया. This feature again removed, this feature again removed. आपके पास मान लिए 10 फीचर्स थे and ये 10 था मान लिया, and 3 features has been removed because the coefficients is 0 of these features. So only 7 features आपके पास रह गए. Yes. So now this technique you can say the features extraction. फीचर्स एक्सट्रैक्शन में भी हमने यही किया था. पीसीए में आप लोगों ने देखा था, आपके पास 3 फीचर से उसको हमने 2 में बदला था या 3 से 1 में बदला था, एक एग्जांपल लिया था. या 10 फीचर्स थे उसको हमने 5 में कन्वर्ट कर दिया, वॉट एवर. सो अगेन एंड अगेन वी आर रिड्यूसिंग द फीचर्स. सो यू कैन से दैट इज द L1 is also the features extraction technique. Yes. So what is the means of that? Try to understand. In the features, some features is like that. Again, I am taking the example, the वही example CGPA वाला, कि you have the 12th marks number, 10th marks, BTech के marks, whatever. Okay, and some IQ value. Okay, यहीं पे मैं कहूँ कि what is the temperature when you are going for the interview? Okay, what is the room temperature? Your body temperature. What is the room temperature? What is the environmental conditions? ठीक है, रेनी था या दोपहर थी या what? So these features may not affect the CGPI because these features may affect the CGPI. Okay, so maybe this is the 0, this is the 0. The coefficient of these features will be 0. So we can neglect these features. So जो feature आपके important नहीं है उनको हम हटा रहे हैं. Okay, so on the basis of that we are increasing the value of R2 score. Yes. So this is the thing. So for that you can use the L1 regularization. तो सिंपल रिग्रेशन से ये अच्छा टेक्निक आपके लिए काम करेगा. ओके, सो यू कैन यूज दिस L1 regularization एज ए फीचर्स एक्सट्रैक्शन टेक्निक. ओके, क्लियर है बेटा? यहाँ तक क्लियर है सबको? हेलो.
Yes.
ओके. और Every time when you are using the regression, you have to go for this L1, L2 or elastic net, because there is no harm to use these things. Whenever you are using the regression problem, you are applying your code, you can go for these things, ridge, lasso, and elastic net. So, and you can compare your R2 score. So wherever the R2 score is good, you can apply this thing. Okay. Now the third thing is elastic net. So you can understand now, so that is the combination. Okay. So again, I am writing the elastic net. The elastic net is the combination. So again, I am writing the loss function. So what will be the combination? You can write here. That will be your, sir, that will be the summation of I is equal to 1 to n. And this is the yi minus yi cap square. Yes. And this will be lambda 1. I can write, or I can write one more word, that is the a. Okay. M square. This is the ridge. Till now it is ridge, and we in the lambda we can use the b, some hyperparameter, and you can use the second, that will be the lasso. So this will be the loss function for the elastic net. Clear? Now again, that is the procedure when if you want to find out the m or c, so you can derivate with the del L by del m and del L by del c, and that will be equal to 0. You can find the value of m or c. Clear? Yeah. So I'm taking only the model that is have two variables. Sorry, one input and one output. If that is more input and more output, you can use the vector. So you can either you can use the word w here. Okay, like that, w square. So w will be the combination of w1, w2, w3, like this. So this is the vector. Okay, so now I'm using only one thing, so you can use like this. So the concept is there. This is the concept. But if you will use the sklearn, you will find two things, two hyperparameter here. Okay. So one is you will find this is a plus b is equal to some L value, or you can say some lambda. And this will be the L1. Okay, wait. The L1 value, this L1 will be is equal to the a by a plus, not I forget this thing. एक आपका फॉर्मूला जनरेट होगा, एक सेकंड वो निकल भी आएगा. When I am taking the 0.5 and 0.5, this will be 1. Yes. So what is the means of that? When you are going, you are giving the preference of lasso and ridge regularization 0.5, 0.5. Okay. The value will be means half you are using the lasso, half you are using the ridge. And it if you are giving like this 0.9 and 0.9, 0.1. Okay, 0.9 and 0.1. What is the means of that? The ridge regression playing the vital role here in this type of thing, because the value is 0.9 here, and the lasso regression is playing less than the ridge regression. So you can choose this because these are the hyperparameter. You can choose these type of value. Is this okay? So this is, I think, some L1, and this is one ratio A by 1, A by B. So this is the A by B. So this will be the, again, L1 you can say. So with the help of this thing you can find. Yes. तो कुछ इस तरीके की क्वेश्चन है. So just because sklearn में इस तरीके के दो हाइपर पैरामीटर आपके फाइंड आउट होंगे. मैं दिखा भी देता हूँ अगर नेट चल रहा है sklearn में. इलास्टिक नेट. So two type of parameter you will use. So one thing is that, okay, some alpha value and this L1 ratio, that is 0.5. So two parameter you will provide. This is, I think this is alpha. A plus B is equal to alpha, you can say. Okay, and this is the L1, A by B. Something is like that. So this is 0.5 and 0.5. This is 1. Alpha is 1 here. that is written here. So two parameter you will use. Okay, L1 का रेशियो शायद ये नहीं है, a प्लस ये होगा शायद, ये फॉर्मूला कहीं इसमें लिखा होना चाहिए. I think that is, हाँ लिखा है. Okay, ये this is written alpha is equal to a plus b and L1 ratio is a by a plus b. So we are using this type of, on the basis of that you can find the value of a and b. So a is representing your rich value and b is representing your lesser value. So you can change these value on the basis of that. You can find which one is better, which the R2 score you can find, and you can find whatever the model is representing. Okay, so now I am telling you 2-3 points I just want to add you. Okay, now I'm showing this ridge regression. Some points first. How are the coefficient affected? Try to understand. We have some data. Okay, so this is the diabetes data and target is something कि आपको एक साल का डेटा है आपके पास, जो एज दिया है, सेक्स दिया है, बीएमआई इंडेक्स है, बीपी का है, और सम डेटा है आपके पास S1 S2, और टारगेटेड है कि आपका ये वैल्यू कितना है. जो ज्यादा रहा है तो आपका डायबिटिक ज्यादा हो, और कम रहा है तो आप डायबिटिक कम हो. सम टारगेट आपको दे रखा है. नाउ ऑन द बेसिस ऑफ दैट वी विल यूज द ridge regression and the lasso regression. So first what we are doing, we are dividing data into two parts, that is the training and testing. Okay, on the basis of that we are applying the ridge and we will find the R2 score. So ridge से मैंने जब इस डेटा को find out किया, so I am going for the everything, every feature I just want to see कि उसका effect क्या आ रहा है. Okay, so you can see कि मैं different अल्फा की वैल्यू यूज कर रहा हूं और उसके बाद उसका R2 स्कोर क्या जनरेट हो रहा है. सो इट इज रिटन हियर. सो वेन एवर द अल्फा इज 0. अच्छा मुझे यहाँ बताओ पीपीटी में, अगर मैं रिच को देखूं, रिच रिग्रेशन को देखता हूं, फर्स्ट था मेरा लॉस फंक्शन, यहाँ लिखा है. अगर मेरे यहाँ अल्फा या लैम्डा बोल रहा हूँ, जो ये लोग अल्फा बोल रहे हैं जिसको, वो लैम्डा है आपका, इसकी वैल्यू अगर 0 कर दूं तो ये क्या बन जाएगा? व्हाट इज दिस? दिस वैल्यू विल बी रिमूव्ड. यस, so this is the simple regression. So first thing is that, okay, first thing is that this is the simple regression. और यहाँ पे उन कोफिशिएंट्स की वैल्यू जनरेट हुई है, जो फीचर्स हैं उनके कोफिशिएंट्स की वैल्यू इसने शो किया है. और वहां R2 स्कोर आपका कितना आया है? दैट इज द 0.44. When it is taking the value of alpha is 10, okay, the R2 score 0.15. So you can see something is increasing or decreasing. Decreasing somehow in this part, that is decreasing. So you can see the impact. Okay, कि अब मैंने अल्फा की वैल्यू और ज्यादा ले ली. So what is happening? This is और आपका क्या कर रहा है? डिक्रीज कर रहा है. R2 स्कोर और डिक्रीज कर रहा है. यस, अल्फा की वैल्यू और ज्यादा आपने ले ली तो क्या हो रहा है कि दैट इज मोर डिक्रीजिंग.
डिक्रीज होता जा रहा है सर.
हाँ, डिक्रीज हो रहा है. मीन्स यू हैव टू एडजस्ट द थिंग कि आपका R2 स्कोर ज्यादा डिक्रीज ना हो जाए. ओके, सो मैं हाइपर पैरामीटर की पहले बात करा कि अगर आप लोग को ये भी जो चूज करना है, हाइपर पैरामीटर भी आपको डिफरेंट लेके देखना पड़ता है कि किस वैल्यू पे आपका R2 स्कोर ज्यादा अच्छा वर्क कर रहा है. इज इट ओके? सो एवरी टाइम इट में इफेक्ट ऑफ द कोफिशिएंट्स वैल्यू. ओके, कि कोफिशिएंट्स और R2 स्कोर पे आपका इफेक्ट करता रहेगा. इज इट ओके? यस. अब देखो यहाँ पे मैंने क्या किया, डिफरेंट अल्फाज पहले से ही ले लिए हैं. 0.0, 0.001, 0.01, डिफरेंट अल्फा की वैल्यू मैंने ले लिया है. अब मैं चेक कर रहा हूं, देखो यहाँ पे चेक करो, रिज में कर रहा हूं. स्टार्टिंग में मैंने 0 लिया, इस टाइम पे ये वैल्यू 0.9 थी. अब जब मैं इसको ले रहा हूं 10,000, तो इसकी वैल्यू देखो ज्यादा डिक्रीज की है, 0.02 पे आ गई. तो कोफिशिएंट्स की जो वैल्यू थी उसको देखो, फर्स्ट टाइम पे -9 है और यहाँ पे 0.02 आ गई. इसी तरीके से ये देखो, ये बड़ी वैल्यू है, माइनस में बड़ी वैल्यू है, -204 0 पर, बट यहाँ पे आपकी वैल्यू क्या जनरेट हो गई? 006. तो डिफरेंट अल्फा की वैल्यू से आपके कोफिशिएंट्स में जिसकी वैल्यू बड़ी थी वो ज्यादा इफेक्ट होता है. ओके, सो रिमेंबर दिस थिंग कि आपकी जो ज्यादा फीचर्स में ज्यादा बड़ी वैल्यूज हैं, अगर अल्फा की वैल्यू आप बढ़ा रहे हो तो उस पर ज्यादा इफेक्ट आएगा. सेकंड थिंग थी ये। यस, एवरीथिंग इज क्लियर। तो आप जब चेक करोगे अगर डेटा सेट पे, तो डिफरेंट वैल्यू पे लेके चेक कर सकते हो कि क्या इंपैक्ट पड़ रहा है उसके कोफिशिएंट्स पे। थर्ड चीज जो बताने को थी वो इसी में, इस प्लॉट को एक्चुअली यूज करके इन्होंने दिखाया कि डिफरेंट डिफरेंट वैल्यूज को लिया तो कोई भी वैल्यू जीरो नहीं पहुंची है। हम लोगों ने जब यूज किया है, देखो कोई भी वैल्यू लेस नहीं, रिज है ना ये, तो रिज में कोई भी वैल्यू आपकी जीरो पे, कोई भी कोफिशिएंट्स आपका जीरो नहीं हुआ। बट अगर यहाँ पे रिज यूज कर रहे होते तो आप फाइंड आउट करते कि कुछ वैल्यूज के बाद, वन के बाद, आप जिन जिन फीचर्स का यूज नहीं हो रहा था उनके कोफिशिएंट जीरो हो चुके होते। ठीक है, जिसका इम्पैक्ट कम था वो जीरो पहुंच चुके होते, ये जीरो के पास तो पहुंचे हैं। देखो 0.006 पे आ गया, बट इट विल नेवर, कोई भी वैल्यू आपको जीरो नहीं दिख रही है। इज इट ओके? यस।
यस सर।
ओके, नाउ अब मैं इम्पैक्ट बायस और वेरिएंस पे भी, इम्पैक्ट जो अभी मैंने बताया उसको भी शो करना चाहता था ग्राफ से। तो एक रैंडम डेटा जनरेट किया है, इस इक्वेशन से मैंने एक रैंडम डेटा जनरेट कर लिया। ठीक है, ऑन द बेसिस ऑफ दैट अब मैं क्या कर रहा हूं, यहाँ अल्फा नहीं है, यहाँ पे ये देखना, ये अल्फा नहीं, यहाँ पे ये एम की वैल्यू है। अल्फा यहाँ गलती से लिख गया है, यहाँ अल्फा लिख दिया एक्स पे, इसलिए यहाँ पे अभी मैंने पूरा कोड रन नहीं किया तो दोबारा नहीं कर रहा, नहीं तो वो चला जाएगा शायद। एनीवेज, ये एम वैल्यू है, डिफरेंट डिफरेंट एम की वैल्यूज पे आपका लॉस कितना है। तो ट्राई टू अंडरस्टैंड स्टार्टिंग में क्या है। स्टार्टिंग में पहले हम लोग देखेंगे 22 का वैल्यू। ठीक है, 22 यहां से स्टार्ट हुआ। ठीक है, समथिंग हियर, फिर वो कम हुआ, 22 कम हुआ, उसके बाद थोड़ा सा इंक्रीज होता गया। 22 को मैंने क्या बताया था, आपके दिमाग में क्या आना चाहिए, दैट इज द ट्रेनिंग एरर। ओके, ट्रेनिंग एरर मेरा क्या हो रहा है कि मेरा स्टार्ट हुआ ऊपर से, ज्यादा थी, फिर वो ट्रेनिंग एरर कम हुई, और फिर थोड़ा थोड़ा इंक्रीज करना स्टार्ट हुई, ट्रेनिंग एरर। यस, एवरीवन इज ओके? और ये स्लोप बढ़ाने
यस।
पे, ये अल्फा नहीं है, ये स्लोप धीमे धीमे जो हमने बढ़ाया उससे इंपैक्ट ऐसा आ रहा है। अब नाउ हम बात करते हैं वेरिएंस की। यस, तो वेरिएंस स्टार्टिंग में क्या था, वेरिएंस बहुत ज्यादा था। यस, हाई वेरिएंस था। हाई वेरिएंस होता है तो मैंने क्या बताया था, सिस्टम कैसा होगा, ओवरफिट होगा। यस और नो?
ओवरफिटिंग।
ओके,
ओवरफिटेड।
वेरी गुड वेरी गुड। तो हमारा सिस्टम यहाँ से ओवरफिट से स्टार्ट हुआ, धीमे धीमे ये कम होता गया। ओके, और धीमे आप देखोगे जैसे जैसे ये आगे बढ़ता गया है, ये हमारा लॉ, सॉरी, हमारा वेरिएंस क्या है, कम होता गया। ओके, तो ये हमारा लो पे पहुंच गया। मैंने हमेशा क्या बोला कि हमें सिस्टम में कैसा सिस्टम चाहिए होता है, बताओ, जो लो वेरिएंस और
लो वेरिएंस
लो
लो
बायस
बायस।
होना
लो
चाहिए।
बायस।
अब इन दोनों को देख के आपको क्या लगता है, जो कट पॉइंट है ये देखो, ये वाला कट पॉइंट यहाँ पे मिल रहा होता है। इस टाइम पे देखो कि आपका वेरिएंस भी कुछ लो है, ठीक है, और बाइस भी लो है। इसके बाद ये देखो इंक्रीज
बायस भी
करना
लो।
स्टार्ट हो रहा है। ठीक है, समहाउ ये जो पॉइंट, कट वाला पॉइंट जो आता है, वहीं पे हमारा सिस्टम क्या हो रहा है। और यहाँ पे एक चीज और देखो कि यहाँ पे जो लॉस होता है ना, वो हमारा मिनिमाइज, ऑप्टिमल मिनिमाइज के आसपास रहता है, कि इससे नीचे जब ले जाते हैं यू विल फाइंड कि यहाँ पे हमारा लॉस सबसे कम के आसपास होगा, भले ही इस ग्राफ में थोड़ा सा नीचे यहाँ पे गया है। बट दिस टाइप ऑफ मॉडल जो यहाँ पे कट पे मिल रहा है, दैट विल बी अप्रोप्रिएट फॉर योर मशीन लर्निंग मॉडल। So whenever the bias and variance is low, you can say that model should be preferable for the machine learning model. Is it okay?
यस,
और
सो
ये
दैट
जो
लॉस
ब्लू,
वी कैन से ऑप्टिमल लॉस, राइट?
या ऑप्टिमल लॉस, मतलब इस टाइप के हम मशीन लर्निंग मॉडल को ही प्रेफरेंस में लाते हैं। ओके,
हम्म।
इवन दो यहाँ पे थोड़ा सा इस मॉडल में हो सकता है कि लॉस यहाँ पे थोड़ा सा ज्यादा कम है, इस पॉइंट पे निकालोगे तो थोड़ा सा ज्यादा हो सकता है, बट इवन दो, क्योंकि हमारा बायस, ये वेरिएंस, सॉरी बायस हमारा
या
यहाँ पे ज्यादा
बायस
हो गया है,
पर
तो
है।
ज्यादा हो गया है, दैट्स व्हाई वी विल नॉट प्रेफर दैट टाइप ऑफ मॉडल। यस, so this is the story, every time
यस
you
सर।
have to you have to find out this type of curve, कि वहां पे बाइस और वेरिएंस का एक बैलेंस बनाना रहना चाहिए। तो यू विल फाइंड कि ये वाला जो एरर आ रहा है, इस टाइप के मॉडल को, यहाँ पे जो हमारा मॉडल होगा इस पॉइंट पे, उस पॉइंट को ही हम प्रेफरेंस में रहेंगे। तो हो सकता है कि वो लाइन जो हमारी आ रही हो, वो ये रेड वाली लाइन हो या ब्लू वाली लाइन हो, इस वाले मॉडल को लेंगे और सभी को हम लोग नेग्लेक्ट कर देंगे। यस, इज दिस ओके? ओके,
यस सर।
Yes, sir.
हाँ, तो लॉस फंक्शन पे इसका इम्पैक्ट और मैं दिखाना चाहता था। एवरी टाइम व्हाट विल हैपन, देखो जब अल्फा हमारा लैम्डा की वैल्यू जीरो है, तो ये ब्लू वाली लाइन हमारी आई है, तो आप देखो मिनिमाइजेशन यहाँ पे 25 के आसपास हो रहा है या 20 के आसपास होगा। जैसे जैसे हम अल्फा की वैल्यू बढ़ाते गए, तो हमारा ऊपर की तरफ जा रहा है, और जब अल्फा हमारा 100 हो गया तो ये लास्ट वाला कर्व आया है, तो ये टेंस टू जीरो हो रहा है। ठीक है, तो लॉस हमारा टेंस टू जीरो हो रहा है जैसे जैसे हम अल्फा की वैल्यू को इंक्रीज कर रहे हैं। तो समटाइम्स यू विल फाइंड कि अल्फा की वैल्यू को बढ़ाने पे आपका क्या होगा, ये टेंस टू जीरो जा रहा होगा लॉस। ठीक है, तो लॉस फंक्शन, और यहाँ पे हम 3D कर्व में अगर देख रहे हो तो वही चीज यहाँ दिखाने की कोशिश है कि हमारा जीरो था तो वो बहुत दूर था, फिर धीमे धीमे हमने अल्फा की वैल्यू को इंक्रीज किया तो इट इज टेंडिंग टुवर्ड्स द जीरो। ठीक है, उसकी वैल्यू जो होगी वो आपकी जीरो की तरफ बढ़ना स्टार्ट कर देगी। इज इट ओके? तो अल्फा का इम्पैक्ट क्या आएगा, तो यू कैन सी द इम्पैक्ट ऑफ अल्फा। इस ग्राफ में एक रैंडम से जनरेट किया, और उस ग्राफ में हम किस तरीके से, तो कई फैक्टर हमारे हो जाते हैं। इन फैक्टर्स को आप अगर नहीं देख रहे हो तो यू कैन गो फॉर द R2 वैल्यू, कि आपकी R2 वैल्यू बैलेंस में होनी चाहिए। ओके, कि R2 वैल्यू अगर टेंस टू 1 है दैट इज ओके, अदरवाइज यू हैव टू डू सम एक्सपेरिमेंट विद द डेटा, कि आप लैसो लगा रहे हो। अगर इन दोनों के बाद भी नहीं होता है कि लैसो और रिज लगा रहे हो, देन यू कैन गो फॉर द इलास्टिक नेट। इलास्टिक नेट में दैट इज अगेन द कॉम्बिनेशन, तो वो बैलेंस्ड वैल्यू प्रोवाइड कर देगा। तो थ्री थिंग्स। So with the help of regularization, what you are doing, you are increasing your accuracy, you are increasing your scores, R2 scores. Yes. So lastly, regularization, what is doing? Actually, this is reducing your overfitting, okay, of the system, of the model. Okay, so main advantage of the regularization is the reducing the overfitting value. Everyone is clear on this point? Yes.
Yes, sir.
So on there
Yes,
are
sir.
only the three things. This is the value you have to find out, means this lambda m square, lambda m and the combination. Okay, on the basis of, और सबसे बड़ा फायदा क्या है कि लीनियर रिग्रेशन में इसकी लाइब्रेरी भी दी हुई है, तो यू कैन डायरेक्टली यूज दैट लाइब्रेरी। ओके, कहाँ स्टार्टिंग में ही, सो विद द हेल्प ऑफ द लाइब्रेरी यू कैन अटेम्प्ट द प्रॉब्लम्स। क्योंकि देखो रिसर्च में भी क्या होता है कि यू हैव टू सॉल्व द प्रॉब्लम, और हम एक्यूरेसी को इंक्रीज करने की कोशिश करते हैं हर एक टर्म में। ओके, सो यू कैन यूज द लाइब्रेरी एंड यू कैन फाइंड द R2 स्कोर, ऑन द बेसिस ऑफ दैट डायरेक्टली यू कैन गेट द आंसर। यहाँ पे कोई कंपटीशन नहीं है आपका कि आपको पूरा स्केच से ही लिखना है प्रोग्राम। मैथमेटिक्स कभी कभी नहीं भी पता है तो यू कैन अंडरस्टैंड एंड यू कैन अटेम्प्ट दिस प्रॉब्लम। यस, एवरीवन इज क्लियर?
Yes,
So
sir.
what is the
Yes,
means
sir.
of variance? What is the
Yes, sir.
means of bias? What is the trade-off? How we can say what model should be appropriate for the machine learning model? What is the regularization and how we can use the regularization? That part is clear to you,
Yes, sir.
everyone? So totally we can say this is the regression part. Okay. After that, I will not use the regression word, because after that we will go for the classification and clustering thing for the machine learning model. But in the regression part, you have heard about the simple regression, multiple, after that polynomial, after that regularization, some bias and variance problem you have solved. Okay, so this is the story about the regression. So I think everyone should clear about this. कल मैं आपको कुछ इसकी एक्सरसाइज भी दे दूंगा करने को, रिज और लेसो और इलास्टिक नेट की, सो यू कैन अंडरस्टैंड मोर बेटर। एंड कुछ आप ग्राफ बनाओगे लास्ट वाली थर्ड के सेकंड पार्ट में, अगर आप प्ले करोगे उसमें जो मैं देता हूँ कि फन एक्टिविटी नाम से, इफ यू विल प्ले विद दैट एक्टिविटी यू कैन फाइंड कि आपकी ओवरफिटिंग कैसे हो रही है। द ग्राफ विल चेंज। ओके,
Yes,
एंड
yes.
you can find how the overfitting is going on. Okay, so these activity you can do. So I'm stopping today here only. Okay, so in the next session we will see